Right, this is a talk about element symbols, the particles that we can learn about from those element symbols, and keeping track of particles. When we use our periodic table, we can learn a lot about atoms. So looking at carbon symbol, for example, we can find the atomic number that's in the top left of the box. We can see the symbol of carbon, and that's a solid letter C, which tells us it's solid phase of matter at room temperature. Notice that nitrogen has bubble letters, which means that it's a gas at room temperature. Bubbles are filled with gas. And then finally, two atoms on the periodic table, mercury and bromine, have leaning letters, which are liquids at room temperature. So the symbol, then we can get the element's name, and then the average atomic mass or the atomic weight. Also, just the atomic mass is sometimes used. So that's all straight off the periodic table in this tiny little square information we can learn about atoms. So the atomic number tells us the number of protons, and this is what identifies the atom. So every atom has a unique number of protons. In a neutral atom, the number of protons is equal to the number of electrons. So all the elements on the periodic table, since they're atoms, the protons and electrons are the same number. The symbol is just the shorthand version of the atom's name. And then the average atomic mass is a weighted average. So it's looking at all the different versions of the atom. There are isotopes of an element, and it's looking at how prevalent those isotopes happen to be. And then it's looking at the mass of each of those and relating it to the prevalence of each isotope. And that's the average atomic mass or the atomic mass. It's measured in atomic mass units, which is abbreviated AMU. So we can take that periodic table square and turn it into a nuclear symbol, which is a very handy way of, again, giving a lot of information about an atom. Specifically, it also helps us figure out about different isotopes of that atom. Always present, you have to have the symbol and you have to have the mass number. These are the two must be present items in a nuclear symbol. You can write the atomic number, and when we do our work, I'm going to have you add the atomic number. Then if it happens to be a charged particle, there will be an ion charge. If it happens to be part of a compound, or if it's a Hunkelbrief, it'll have a subscript. The mass number we're going to get by taking the number of protons and neutrons and summing them together. So that's going to be the top left number of a nuclear symbol. The ion charge is how many electrons compared to protons. And then the subscript's describing how many of that atom are in the formula or in the compound. So we need to know a couple formulas, and these are something that you should write down in your notes or on a note card. Protons are always going to be equal to the atomic number, so it's really easy to find. Since the symbol of the element's listed, you're going to be able to use that symbol to cross-reference that against the periodic table. And since the periodic table has the atomic number, you can figure out protons. The neutrons are going to be the mass number minus protons. In other words, it's going to be the top left minus the bottom left. Then the electrons are the protons, and since protons are the same as the atomic number, that's going to be the bottom left number of a nuclear symbol minus an ion charge. So what does this kind of look like? On a problem like this, I have two problems here. The first one, it's aluminum 27. I'm going to find aluminum on my periodic table. I see it's number 13. I'm going to add the atomic number on the bottom. So now the atomic number is useful because if we have 13 here, I can put 13 for my protons, and that's also the same as the atomic number. To get my neutrons, I'm going to do top left minus bottom left. 27 minus 13 is 14. And then you're going to do your bottom left minus your top right. So 13 minus no charge, so 13 minus 0 is also 13. The mass number is your top left number, or it's protons plus neutrons. 13 plus 14 gives you 27. So by adding that bottom left number, it gives us kind of a pivot point to figure out the rest of this row. 13 goes in the protons, goes in the atomic number. Top left minus bottom left is neutrons. Bottom left minus top right, electrons. then either protons plus neutrons or just the top left number is the mass number. This problem, I need to figure out what atom I'm talking about. So since protons is the same as the atomic number, I can again use that number and correlate it against my periodic table. So 15 is the number I'm looking for, and the symbol is P. So we're talking about phosphorus. So I need to draw my symbol, P. Bottom left number is the protons. Now to get to the mass number, I need to do protons plus neutrons. Protons plus neutrons is 31, and I can fill that in right here. The last thing to check is see if there happens to be a charge that goes in that space right there. Protons and electrons have to be the same number for there to be no charge. If there is a charge, you're going to do protons minus electrons. That'll tell you what your charge happens to be. 15 minus 15 is 0, so no charge here. If this would have been a 16, 18 minus 16 gives me a -1 charge. Had this been a 14, 15 minus 14 would have given me a +1 charge.